So our story begins in the 16th century with these two men. Guy on the left is Nicholas Copernicus. He said something completely revolutionary. We go round the sun. At that point, we thought, no, everything revolves around us. And he went to church and said, can I talk about this? They said no, and he ultimately died. Then Galileo came along with a telescope, and he looked up into the heavens and he saw evidence that we went around the sun. He saw evidence that Jupiter had moons that went around that, and he went and said, can I talk about this? Was told no, and he died. But we know today that they were right, and that our sun is actually part of the Milky Way. And the Milky Way itself is part of the local galactic group, which in itself is part of the Virgo supercluster. Every little white dot on here is a galaxy. That's a galaxy containing, about the size of our Milky Way, contains between 400 and 600 billion stars. That's a lot of stars on that picture. And bearing that in mind, it raises the question, are there other planets out there? And is there life on them? The first part of that question is very simply answered. Yes, there are planets out there, we know this. But even back as far as the time of Newton, we were open to the idea. Newton wrote in his Principia, and if the fixed stars are the centres of similar systems, they will all be constructed according to a similar design and subject to the dominion of one, which is the first sort of acceptance of the idea of extrasolar planets. And it wasn't until 1992 that we found this is an artist's impression, of a planet orbiting the pulsar star that was lovingly named PSR B1257 plus 12. It was found by these two men, Alexander Wolfgang and Dale Frail. And since then we've been looking at the planet. We haven't been very good until this was launched. This was the Kepler telescope. It was named after the 17th century German astronomer, Johannes Kepler, who came up with his laws of planetary motion, which helped Newton to develop his gravitational theories. Kepler, the telescope that is, was launched in March 2009, and by February 2011 they found 1,235 new candidates for being a planet. And by February of this year that had raised to 2,321. So how do we actually find these planets? The method used by Kepler is something called the transit method, which is where if a planet passes between you and its star, you see a reduction in the amount of light. You have to bear in mind though that this is a very small reduction. The Earth is 1 million times smaller than the Sun, and even a Jupiter-sized planet passing in front of a star similar to our Sun would produce a dimming of about 0.01%. So we're talking tiny here. Another way of doing it is through a radial velocity method, which is where, as a planet orbits a star also orbits a planet, though not quite in the same way. What happens is the light on this side gets squashed, and we see it as blue. And on this side, it gets scratched, and we see it as red. If we look at the star and we see them, we can tell that there's something going around it. We may not be able to see the planet, but we can tell there's something there, and it must be a planet, because it's the only thing big enough to do that. Another method, and probably the most straightforward, is that of direct imaging. That is a planet. Simple as. This is a picture taken in infrared light, and it's of Beta Pictoris. The picture was taken in 2003, and this planet, Beta Pictoris B, was announced in 2008. And there are also other methods that we use, such as gravitational microlensing. I haven't got time to go into it, if you want to ask me, I think it's fine. And as of Monday, we have just confirmed 838 extrasolar planets. But astronomers estimate that there are probably over 160 billion in our galaxy alone. That raises another question. Are we alone? And will we ever meet ET? And if so, why haven't we found life yet? The answer to this is that life is very, very picky. and complex life is even more so. We know that complex life can't really survive very well above 50 degrees and can't survive at all without liquid water. You have to bear in mind that we're working with a sample of one Earth, so we have to go by whatever we have on here. So what astronomers have done is worked out something called the Goldilocks zone, which is how a zone a certain distance from the star, depending on its brightness and its size, of where a planet would be too hot and could still have liquid water on it. So depending on, for a star our size, the size of our sun, rather, depending on who you ask, it's between 0.75 and 3 astronomical units, which is the distance between us and the sun. You may remember this. This is Kepler 22b. On the 5th of December last year, there was a huge uproar in the media because this is the first planet that we found within a habitable zone. There's a size comparison for you. Kepler 22b is 2.4 times the size of Earth, and is within that green Goldilocks zone. Since the discovery, it's been much quieter, but we have found 5 others as well. None of these have yet been confirmed as habitable because we don't know what they're made of. The problem is, all of them could be gaseous planets. You couldn't live on Jupiter, you'd fall straight through. But so what we do is we look at emission and absorption spectra. Certain elements give off and absorb certain frequencies of light, and by looking at the light given off, we can tell what's in there. If we've got a lot of oxygen and a lot of nitrogen, then you can sort of tell that there's something going on there, because these are produced en masse by biological reactions such as respiration. So, back to ET. Just now I've been talking about the possibility for life. Now comes the question of intelligence. The Oxford English Dictionary defines intelligence as the ability to acquire and apply knowledge and skills. So, this lady, Jill Tarter, is the director of the Search for Extra-terrestrial Intelligence setting. And the way that they search for life is by using technology as a proxy for intelligence. So using 350 of these as a person for size comparison. This is the Allen Telescope Array out in California. Using these, they look at stars and the planets that they know are there, and look for radio waves at set frequencies, at constant frequencies, because they would have to have an artificial source, so an intelligent civilization that's learned how to work a radio. Another way they do it is by looking for bursts of light that last less than an nanosecond, like lasers. And one of the most famous members of SETI was the founder, was this man Frank Drake, and he came up with this equation. It looks horrible, but it's much more simple than it looks. It's just multiplying a load of numbers together, and it gives you an estimate for the number of civilizations that we can communicate with. That's n. The numbers are the rates of the number of stars formed per year, the fraction of those that then have planets, the number of those planets which could support life, the fraction of those that then go on to create life, and then the amount of fraction that's then intelligent and develops communication, and finally the length of time for which those signals are given off. That is very vague. We don't know. You get people who are very pessimistic and say that in about 10 years we'll have blown ourselves up through atomic warfare, and then you get other people that say we could last for 9 million years, like this. So Drake did this equation and came up with that number. That's quite a range. What people have done more recently, though, is they've looked at some different numbers, some slightly more sophisticated numbers, now that we have the technology to look at and work out how many planets there are. So using these numbers, we've had to assume here that any planet that develops life will develop intelligent life, and all the intelligent life will produce technology that we can detect, we get this number. So somewhere between 2,000 and 2 million civilizations in our galaxy that we could theoretically contact. It really does depend on which numbers you look at, though. The most pessimistic that I've seen is 8 times 10 to the minus 20, which is very, very small, and says that not only should we not be here, we're probably alone in our galaxy and the universe. And then the biggest is 83 million, which is huge. So, will we ever actually find these aliens? I think yes. I think we will, because the universe is so big that it's almost impossible for it not to, for them not to exist. But as to whether or not you'll wake up tomorrow to headlines of us communicating with a new race of extraterrestrial creatures is another matter. Because even taking our highest estimate of 2 million civilizations, it's like searching for a needle in a haystack. You have to find the planet first to know where to look. And that just takes a huge amount of luck. And luck is the most important factor in the search for extraterrestrial intelligence. Because you can have as much amazing technology as you wanted, but unless you look in exactly the right place, exactly the right time, you miss the tiny window that you have to spot and maybe even contact